June 2012 Core 1 question 6 is our circles. We've been told that this point here in the middle here is the centre is 5, 8. We haven't been told what the radius is, but we can see it's the distance from there to there. That's the x distance, so the radius is going to be 5, isn't it? The radius is going to be 5. And so our equation is going to be x, take away the x centre squared, plus y, take away the y centre squared, equals, well, we can't just leave it as 5 squared here because we want a number, so equals 25. So let's try and find out if this does fit on the circle there. So let's put out what happens when x equals 2, put that in there, and when y equals 12, put that in there. So we're going to get 5 take away 2, sorry, 2 take away 5 all squared, 12 take away 8 all squared. That's 3 squared add 4 squared, or minus 3 squared add 4 squared. And that's 25. Another line needed. Therefore, is it A? A is on the circle. Because it equals 25, like it said. Well, 5 marks for the next bit. Let's have a think about this. So we've got a tangent at A. Where is A? A is up here, isn't it? A is up there. We've got a tangent to A. Worth drawing a picture as we do this. And that tangent, of course, is going to be perpendicular to the radius there. So that might be the way we're going to approach this. So if A was 212 and C is 5, 8, then if we want to work out the gradient of that line, then we're going to be looking at, so the gradient of that is from difference in the y's, there to there is minus 4, there to there is 3. I think the gradient of that is minus 4/3. So the gradient of our one is the negative reciprocal of that. The gradient of our one is going to be 3/4. So we're going to just use our y take away the y number then. Y take away the y number equals gradient x take away the x number. Have we got to leave it in a particular form? Yes, we've got to leave it all over the left-hand side. So let's times everything by 4. Let's multiply out by the 3. And then bring it all over this side here. I'm adding the 6, so I've got minus 42 equals 0. There's my answer to part B. Part C, I think let's move down now for part C. Let's get some more room. Part C, we're talking about the midpoint and a couple of new points here. I think I might draw this again then. So I've got a circle. I've got my centre here. I've got a couple of points P and Q. In the middle of them is a point M. And we also know what point C is, don't we? Point C, the centre of the equation, was 5, 8. So here's point M. Point M is 7, 12. Show the length of C to M. Okay, well that's all right. So we're just going from 5, 8 going to 7, 12. Same as just what we did the gradient before. The difference there is 2, so we've got to do 2 squared. The difference there is 4, we've got to do 4 squared. And for Pythagoras, we've got to square root it. So this is what the length CM is going to be. Well, that's 4 and 16 is 20. Square root of 20. Square root of 20, well, that's 4 times 5. So we've got 2 times by the square root of... Square root of 4 is 2. Square root of 5. And look, that's in the format they wanted. Now it's asking us to find out the area of this triangle. What do we know about that? We know that's 2 root 5. We know the radius of this circle is 5. And so we could actually just use a bit more Pythagoras to work out what that is, can't we? So PM is just going to be 5 squared, take away 2 root 5 squared, square rooted. Let's work that out. 25, take away 2 times 2 is 4. 4 times 5 is 20. So I think that's root 5. So if that bit there is root 5, that means there to there is 2 root 5. Area of triangle is a half times by this distance here, which is 2 root 5s, times by the height, which is that one there, another 2 root 5s. Well, what are we getting there? 2 times 2 is 4, half of 4 is 2, 2 times 5 is 10. And that's the area of that triangle. Here's the answers. 10. Good. And here's the mark scheme. Here's the examiner's report.